Hello, I'm Mark Brick, and my partner is Eric Forkosh, who's taking the video. I'd like to show you a curve tracer today. It's a very interesting machine. We have many in the lab, but not as interesting and intricately built as ours. We call it the VGA multiplier. Let's take a look inside. See this little baby? This is an Arduino. An Arduino is a microprocessor, but we'll get to that later. Underneath are some relays. These are single throws. Over here we have a voltage multiplier, which feeds in to the amp meter over here. You'll see this very, very large resistor is actually small in terms of ohmage, but large in terms of how much power it can put through it. The power that's being put through it, the separation in voltage across the sides, is going to be amplified by a certain scale, which we'll get to in a moment, and shown as a curve across the independent variable of the input voltage, which comes from the Arduino that we talked about earlier. Let's get to the program. Here you'll see a beautiful GUI. GUI is short for Graphical User Interface, but watch my next video to learn more about that. We call this Curve Tracer version 1.0 because we're sure if you look at the emails attached in the paper, we will send you all the updates you need as we continue to develop this in the years forward. Here is the VCVS. We have a start voltage and an end voltage, and that refers to this V control, which is what is coming out of the Arduino. Let's start with a simple example. You have minus, let's say 1 volt, and let's go all the way up maybe to 3 volts. So now we're going to sweep through V control from -1 to 3. What do we want to go to the amp meter? Let's say, make it simple, 1 times, which means the amp meter will also go -1 volts to 3 volts. Here we have a 1 kilo ohm load, which means for every volt you'll get 1 milliamp across. So let's make this clear on our grid by making a 1 volt to 1 milliamp conversion. Are you ready? Aye aye, Captain. And look at that. There's a bit of a cap because the Arduino can't handle less than 2.5 and greater than 2.5 volts. We could fix this by changing it to a 10 milliamp to 1 volt range. But for the time being, let's see what actually happened. As we noticed, for 2 volts, this is going to be getting 2 milliamps across it, which gives you 2 volts. So if you look, you've got 2 volts into the amp meter, gives you 2 volts, or 2 milliamps, out. 1 gives you 1. That is a perfect resistor load. Let's make this a bit better by not cutting it off, by giving a better conversion. Look at that. Now we're talking. Now 2 volts is 2 milliamps, but that's going to go to 0.2 volts on VI out. This is a nice resistor curve. If you'd like to see our diode presentation, please watch our next video. Thank you for joining. If you have any questions, email me. Find that at the end. Or don't. It's up to you. Have a good day.